Thank you so much. And I'm so pleased to be included in this event. I learned so much from these conferences and from the BCE. So I'm just delighted to be here. I was going to talk about learning to rank because I'm very excited that Google and the other search engines are starting to be more exposed with how they are applying artificial intelligence or neural information retrieval to their performance. And then I saw who was following me in this presentation. And I thought to myself, you can't do it. Like he's actually creating learning to rank, and your presentation is going to look like this. So I wandered and I wandered and I wandered, and my poor beleaguered canine put up with my uh, sort of cognitive dissonance. And then I remembered my very first conference, professional conference as an information scientist, and that was Information Seeking in Context in Dublin in 2005. It was a fantastic conference, and there, Carol Coulthau, who is a noted information scientist at Rutgers, talked about the disconnect between computer science and information science. And I said to myself, this this is really important because the computer scientists and the developers are building the applications that we're trying to optimize, that we're trying to make better and more useful to us as humans. And yet, as Dr. Coulthau observed, we are physically separated at university, at opposite ends of the campus, and that only reinforces our professional disconnect. So I said to myself, this is what it is. This is what I want to focus on with you today. And as I was on Twitter, I came across Christopher Manning, who talked about how he had put together this information retrieval glossary, and of course interjected my latest jihad, which is we humans are the intelligence behind artificial intelligence. And he responded to me, I am such a fangirl for Christopher Manning. I use his uh, textbook in my class that I teach at the University of Washington. But not only did he like recognize my existence for a moment, but he pointed me to this paper by Francois Chollet, and I hope I am pronouncing that right. I took Spanish in high school. And I read this paper. I've only had the opportunity to read it once at 65 pages. I do recommend it to you, um, and I hope to read it again and again. But my key takeaways here from Dr. Chalet is there is no shared definition of what intelligence is, and there's no shared set of tests to find out. So so we're creating something that we don't know what it is. Dr. Chalet concludes that intelligence is the rate at which a learner turns its experience into uh, skills at valuable tasks, but that we need to include some sort of capacity for uncertainty and adaptation. The definition is based on the assessment of intelligence systems, with the definition of intelligence grounded in priors, experience, generalization of difficulty. So that's sort of the landscape that the computer science community is using. The measure of intelligence may be interpreted then as a conversion rate between the current state of information and the ability to perform well under an uncertain future. So that's the landscape of AI as it's now coming into our area. And that's why I want to talk to you about human intelligence and how combined with the code, with what Michael's going to talk about, that we will create a hybrid intelligence, not artificial. And for me, it all starts with John Searle and his conversations about sense making. He tells us that the current world is about sharing knowledge flows and reading context. But reading context is different than reading signals, the signals from data. We learned that here in the States with the presidential elections and the polls and how they were having difficulty predicting what was going to happen. That's because data is not information. It does not incorporate the beliefs and the values, the sense making that we do as humans. Sense making is a state that requires knowledge, and knowledge is the outcome of processed data. Searle refers to AI, and he sees it as two types. There's strong AI, where the system has a mind that can understand cognitive states. It has self-awareness. Then there's weak AI, where the system can only simulate understanding, and there is no mind, no mental behind it. One of my former instructors, Jens Eric Mai, who is now on faculty at the University of Toronto, further illustrates the singularly human aspect of intelligence. Quality of information for us as humans is a spectrum that we consume hieroglyphics on a page, data, we transform it into information for us that is then incorporated and processed into knowledge about something. But the quality depends on these characteristics that machines, applications cannot have. There's context, there's situation. Why am I searching for this information? In what situation, in what environment, and in what emotional state? All of that influences what I pick up, what I do with it, and what it means to me. This is what makes consciousness a current fascination with the computer science community. And I've been on this for about 3 years, and it's amazing to me the level of information, the level of focus, the level of research that's on it. A few years ago, David Galertner, a well-known computer scientist at Yale, wrote a book called Tides of Mind, Uncovering the Spectrum of Consciousness. In this book, Dr. Galertner says, the human mind is not just a creation of thought and a collection of data. It is also a product of feelings, a composite of sensations, memories, ideas that are worked and reworked over a lifetime. Human consciousness is a first person experience, but AI can only be conscious from a third person perspective, that of the programmer, that of the developer. Ned Block, who's a philosophy professor at NYU, felt that consciousness had two distinct dimensions: access consciousness, which is introspection, self awareness, self referential, monitoring our own processing, and phenomenal consciousness, which is what it's like to be conscious. So, what is then neural intelligence? Well, human needs are influenced by feelings, engagement, values, moral codes, while AI is influenced by data, and programming. That means that machine behavior is fundamentally different from human behavior by lacking consciousness or empathy. It operates in a wider socio-technologic spectrum than the human stakeholders it serves. And it should not separate environment, the data that is used to train the system, from the explicit behavior across diverse environments, meaning the use cases that we as information professionals could bring. Influencing machine behavior to represent human needs requires a cross-discipline effort, a human-shaped hybrid behavior. And that starts by developing human machine decision systems where human behavior shapes machine output through intricate involvement in the training. We need to understand the parameters of AI engineering to understand the outputs and also impact on human behavior. We also need cooperation, competition, coordination, and intersection with machine behavior. Neural information retrieval intent operates on what's called the compositionality principle, and that is the meaning of word compounds can be derived from the meaning of the two individual words, the way that they're combined. So the components of language can be broken down into subcomponents. There's query intent, which is the individual words that are possible indicators of what the customer intent is. This uses term co-occurrences, proximity models, to improve retrieval relevance. And we've seen that over time with Google, Bing, and the other search engines. Then there's content units that specify the need, and there are intent units that modify the need in one of many possible ways. Learning to rank, on my base understanding, attempts to capture and interpret hidden customer goals through submitted queries and click to URLs. Neural intent deconstruction looks at queries that are classified as either content or intent. Now, content words are nouns, verbs, adjectives. Google refers to these as entities. And then you have the function words, the pronouns, the determiners, the prepositions, and the conjunctions that the searcher adds to add some specificity in application to their particular need. My understanding of learning to rank is that it tracks customer intent actions, i.e., their query terms and refinements, the dwell time, the number of results considered, click counts, and then the first result clicked rank. What it doesn't incorporate is scan browsing, where information is scanned based on relevance to changing tasks or transient information goals. Marcia Bates referenced this as berry picking. And then review browsing, where some information is integrated into the goal after a deeper review of specific assets or the search engine results page as a whole. I have this battle constantly in my current role as part of a team focused on SEO, that it's not about keywords and that head terms are just a fishing expedition to find a place to start looking in a meaningful way. So, how do we design for neural IR? We need to be that middle part where the miracle happens. And I think we can. Frank Pasquale tells us that searches don't know what they want to know, and that it's up to us to help them realize that. This can't be distilled from natural language processing or prediction or learning to rank for that matter. Designing for machine learning means working together. Behavior cannot be separated from the environment, the data that's used to train the AI. Focus has to be on characterizing AI behavior across these diverse environments that we referenced before. AI can help with correlated behavior. It can interpret actual user data to detect patterns that can then inform design changes. We can contribute to this with the creation of interfaces that capture actual situation behavior that maximizes instructions to ML and AI to become a learning decision tree. Because that's how the AI works. It's like if then, if then, if then, if then. We can provide classification for inputs and effective naming. We can enable design of interaction systems that can restate its understanding of tasks to be performed, providing the transparency that Martin referenced before. We can provide user interfaces that allow the user to bypass machine learning for the explicit logic and implicit logic of the user, and then create a baseline to measure no-go if the system failure would cause serious consequences or irrevocable changes. Is I'm raising my hand. Anyone who's tired of unintended consequences, raise your hands. I think we can make meaningful contributions in avoiding some of those. So my process was to start with guiding principles. This became my North Star, looking at what is it that I'm trying to achieve. I want people to find information that's specific to their needs and roles. How is that going to be applied? And then what would the outcomes be that I want to be aware of and address proactively? I look at creating personas with an empathy profile. There's an idea called the grounded theory that qualitative components that differentiate shared experiences can be supplemented with synthesized beliefs and values where tastes and preferences are represented. And that's what this would look like. You'll notice here in the emotions and thoughts that we're incorporating what could be influencing how the customer or how the searcher is interacting with the display of results, with what the machine perceives as being relevant. Most importantly, we want to start understanding the AI customer journey. The human journey focuses on instinctual actions. Here, phases are influenced by thinking, expressing, and acting. But the AI journey map must be programmatically explicit, as the AI lacks intuitive movement. AI uses decision trees for journey progress. Information professionals can be useful for mapping more explicit and expansive decision trees. More importantly, neural information architecture is going to be becoming, and if not already, crucial. Bob Boyko is on the faculty of the University of Washington Information School and has written a brilliant 6-part book series called Information Systems from the Info Out. In his estimation, much of the influence of AI practice stems from the power of naming objects in the system. Naming is a representative task that illustrates both the complexity and value of the information architecture. Naming is framing an understanding of what everything is and how it fits into the system. So, information architects contributing to LTR would name objects for cross system compatibility, set problem definition and structure, map connections, call out the prototypicality or mental models that are going to drive user behavior, and then to diminish the visual complexity that interrupts uh, consumption or understanding of what is being communicated. Images are much harder to deconstruct for information than text. So I recommend using a soft information architecture that is contrary to the status quo architecture we currently have, which is goal oriented, laser focused on a task. Soft information architecture is behavior based, iterative, and incorporates user output or input to do these iterations. It uses the system to create various methods of presentation and structure to accommodate self evolutionary nature of the system performance. Structure uses the feedback to influence behavior, the inner structure of algorithms, and the physical structure of the actual environment. A behavior based design can better incorporate changing nature of conditions and the impact on the system. But what we really want to do is be on the lookout for the heuristic traps that exist. These come from a wonderful article from the New York Times called What I Learned in Mountaineering School. And the heuristic traps there apply here. Those of familiarity, a false confidence by failing to be vigilant when faced with the known. AI is behind the scenes, so it hasn't dramatically disturbed our landscape, but it's there. Social facilitation. Well, everyone's doing it, so it must be okay. We need a chatbot. Get me a chatbot. Or the expert halo, false confidence in experts that we assume know what they are doing, so it must be okay to follow them without question. In the AI landscape, this is somewhat less obvious than in the search landscape, where you have the thought leaders. Then there's anchoring, clinging to a position because you always have. Every moment you don't turn around, it becomes harder to do so. Just ask the Donner Party, who set out to get from the East Coast to the West Coast in the United States in an unrealistic period of time and ended up trapped in the mountains in the snow. There's scarcity, and this one drives a lot. If I don't do it now, I never will. In skiing, it's referred to as powder fever. And last but not least, acceptance. Well, everyone else is doing it, and I want to be like them. So, why this? Why now? Why us? Algorithmic bias is an absolute fact, and it's not intentional. Technology inherits the ideas and values of the group that develops it, and the group that is developing it is largely insulated into certain class, race, culture. Ben Schneiderman, winner of the ACM Turing Award this year, called out for a national algorithm safety board to monitor and assess the safety of algorithms as they access social systems. We can prevent use cases that are too narrow, like the early Google image recognition, where the resources only coded in a specific number of shades, skin shades, so that in that decision tree, if you don't match the skin color, then you must go to the next category, that being gorillas. Or we could try and circumvent poorly conceived objective outcomes. Who in their right mind would develop a psychopathic AI application? And what could possibly go wrong with this? We could possibly redirect them from poorly designed training data, such as Microsoft, that in developing a chatbot decided to train it on all of Twitter. Who in their right mind would send an application that can literally consume all of Twitter and then come back with a misogynistic, racist, foul mouth chatbot? More specific to learning to rank is the idea of search SERP abandonment. Uh, Learning to rank relies on SERP abandonment, and studies have shown that 41% of the abandonments were bad and 32% of the abandonments were good, with the remaining 27% associated with alternative reasons. So this is the idea, is what does that reflect when the customer bounces away? There are issues with search abandonment that all of us, I'm sure, are thinking of right now. The system's ability to accurately categorize abandoned queries is compromised because of noisy indicators in user preferences, the emotional state that we talked about, user bias, either position, search engine, cultural bias, the inability of the system to intuit how the customer is using the SERP in order to find or refine or to better understand just on the basis of what they're seeing. Most importantly, the idea of explore and exploit hurdles. So the idea of explore and exploit is the system is that's how it learns. But if the system goal is to exploit the best results, the highest probability of success to find new ones, how can that be if it's also supposed to present the best results initially? So there's this conflict within sort of the interior logic. Neil Postman, who is communications professional and media professional, gave great uh, observations with regard to the developments of these technologies. He says that all technologic change is a trade-off. That the greater the wonders of this technology, the greater will be the negative consequences, and that culture always pays a price. We're seeing that with algorithmic bias and with the social psychological impacts of the over application of AI. Number two, the advantages and disadvantages of new technologies are never distributed evenly among the population. Some gain, some lose, few remain the same. With predictive search, the end of browsing, information induced blindness, systemic problems need actions informed by information, not just more information. Number three, embedded in every technology, there is a powerful idea, sometimes two or three. We need to focus on all of the functions, not just the profitable ones. For technology, change is not additive, it's ecological. And we are definitely seeing that now. A new medium does not just add something, it changes everything. We have numerous unintended consequences with the applications of AI. I just ran through some of them that are often unpredictable and irreversible. And last but not least, media tends to become mythic. Jaron Lanier addresses this when he talks about computationalism, which is an enthusiasm for a technology that becomes sort of an idolatry. AI is the new hammer, so everything must be a nail. The capacity for good or evil requires human awareness and participation. That's us, the human factors professionals, included in the development at the beginning and then the execution. Dr. Postman wrote this in 1998, and yet it is still so important now. So I hope with my screed that I've inspired you to broaden your scope of awareness, to start paying attention not just to what our media or our publications are talking about AI, but to dive deep and to really, it's hard, I know, keep reading those articles and the research papers on where these applications are going, and within your organization to lobby to be a participant in the development. Better understanding of this landscape and influences will enable us to bring our computer science and our developer brethren colleagues into a better understanding of human factors and how the two can coexist. And last but not least, to embrace these new tools and methodologies so that we can create more humane hybrid intelligence. Thank you.